Hello students, good morning. Today in this video we are going to learn about the redox reaction. The learning objective of this chapter and topic: how to identify and define the redox process. So after the completion of this topic, you will be able to learn how to identify a redox process and second, how to define a redox reactions. So let us begin. Uh, when we look around us, there are so many chemical reactions takes place, such as the rusting of iron, corrosion of metals, and so many processes such as our digestions. So all those chemical reactions has been classified into different categories. In class 10th standard, might you have learned about the redox reactions. There are a small view. Have you seen over there about the redox reactions? But here in class 11th standard, we will discuss in details about the redox reactions. The, when we think about the redox process, in the fascinating word, this redox having the two words. The first is the red and then ox. The word red indicate here the reduction process or reduction reactions, and the word oxidation ox indicate here the oxidation process. So now it is clear here this redox word is the combination of two processes. One is the reduction, another is the oxidation. Is it clear? One is the reduction and other is the oxidation. Reduction plus oxidation. These two processes takes place in a single reaction. When the reduction takes place, there must be oxidation will be also. When the oxidation takes place, there must be reduction also. First of all, we will learn to identify the reduction and oxidation separately. There are different ways to define and identify the redox and oxidation. Redox reactions, that means the reduction and oxidation process. When the scientists started to study about the nature, they look around us. There are so many processes which takes place in presence of oxygen. For example, uh, give me some examples. You think about the first respirations, which is the takes place in presence of oxygen. When we take the oxygen, that go to the in our blood, and there will be the glucose get oxidized bonds and produce the energy. This simple process you know. Another process, the combustion reactions. When any fuels bonds produce the energy, that is react with the oxygen. So on the basis of first atoms, oxygen, we will going to learn that reduction process. The in terms of the oxidation and reduction, we will learn the first method oxidation in terms of oxygen atom. First of all, the oxidation process defined in terms of the oxygen atom. So, for example, let us see A. Any element is A which is being are combined with oxygen and gives you the AO, right? Another, for example, magnesium when react with the oxygen gives the magnesium oxide. This is solid, this is a gas and this is the solid. Here look at what changes we observed when magnesium gets changed into magnesium oxide. Here there is no oxygen, but when you look to the right side in the magnesium oxide formula, there is the oxygen present with the magnesium. So what happened? Magnesium, when changed into magnesium oxide, here we observe the addition of oxygen. What happened? Addition of oxygen. So it is clear that oxidation is the process where the oxygen gets added up. That is addition of oxygen is called oxidation reaction. Is it clear? Now, when think about the reverse process, for example, magnesium oxide get converted into magnesium plus oxygen. Then what happened? When we observe this process, magnesium to magnesium oxide to magnesium, then here is no oxygen and here the magnesium oxide. So what happened here? The loss of oxygen. So another reduction process is the opposite of oxidation, and here we call the reduction is the loss of oxygen, or we can say that loss of oxygen is called reduction reaction. Any doubt? No? Now, this is a question going to you. Sulfur plus oxygen gives the sulfur dioxide. What process takes place? Addition of oxygen. Clear? We call the oxidation. Next, water get converted to hydrogen plus oxygen. Now, what is happening with reference to the hydrogen atom? So, when we look the hydrogen, then we observe that removal of oxygen or loss of oxygen. So, we call that removal of oxygen. So, this is called redox. Is it clear? Hope you will be able to identify the redox process on the basis of oxidation and reduction. On the basis of oxygen atom. On the basis of oxygen atom. Here we define oxidation and reduction process on the basis of oxygen atom. But when the study is going slowly, then we came to know that it is not possible we can define oxidation and reduction process with reference to oxygen atom only, because in our surrounding there are so many chemical reactions takes place which is based takes place without the involvement of oxygen. For example, when the For example, when the sodium react with hydrogen and give the sodium hydride. Now, what kind of these reactions can be classified redox reactions or not? So easily we can classify it redox reactions, but here the parameter has been changed. So the next is in terms of the hydrogen. Now, the first we have learned that the oxidation and reduction on the basis of oxygen atom. Oxygen atom. Addition of oxygen we call the oxidation, and removal or loss we call the reduction. Another parameter of redox reactions or oxidation and reduction is that in terms of hydrogen atom. As I told earlier, there are so many reactions which takes place without the involvement of oxygen. So can we classify them as oxidation and reduction? Yes, we can classify them as oxidation and reduction. Let us see here where the sodium react with hydrogen, it gives the sodium hydride. So here what is happening? Look, the changes observed when the sodium get converted into sodium hydride. Now we observe here the addition of hydrogen atom. So what we call it? Can you say addition of oxygen is the oxidation? So we cannot say the addition of hydrogen is the oxidation. The reverse of this process means where does oxygen get added, we call the oxidation, but where does hydrogen get added, what do we call that process? We call that process redox reduction. In terms of the hydrogen atom, this process is called reduction. So we can define it: addition of hydrogen atom is called reduction. Reduction. Is it clear? Now look the scenario and think the scenario about the reverse of this process. When the sodium hydride will convert into sodium and hydrogen. So what happens? Let us see. Here the hydrogen is present, but here no hydrogen. We can say that removal of removal of sorry, removal of hydrogen atom. Where does removal of hydrogen atom takes place? We call that process is the oxidation. Oxidation. So we can define it as removal or loss of hydrogen is called oxidation. It's called oxidation. Oxidation. So here we can conclude that hydrogen, if get added, then that process is known as reduction, and hydrogen if removed, that process is known as oxidation. It's clear? Means when we combine the both process, both oxygen and hydrogen atoms, so the hydrogen when we define the redox process with reduction and oxidation with reference to hydrogen, that is the reverse of the with reference to oxygen. Is it clear? So hope it is clear that atoms, if oxygen is available, then addition called the oxidation, removal that is reduction, and reverse of the oxygen atoms we define the hydrogen in terms of the hydrogen atom. If the addition takes place, that is process is called the reduction. If the removal takes place, that process is called the oxidation. But do you think this is the sufficient or this is a complete definition? Uh, we can say that this definition is universally proved or universally acceptable. Means can we identify all those reactions on the basis of oxygen and hydrogen only? Answer will be no. We cannot define and classify the reactions, redox reactions, and that is oxidation and reduction on the basis of only oxidation and reduction process. So there is some updatation and addition, and we can say that changes we can observe. For example, when we look the magnesium atoms get react with the chlorine and it may gives magnesium chloride, right? So here we observe there is no presence of oxygen and hydrogen atom. Is it clear? But as we know that the nature of oxygen atom is what? In chemistry, we classify the elements on the basis of their nature as the electropositive and as the electronegative. So, can you say me? Can you say to me that oxygen is an electronegative atom or electropositive atom? Oxygen is a kind of electronegative atom, and hydrogen it is a kind of electropositive atom. So look this, what is happening here? What changes we observed? When the magnesium get converted to magnesium chloride, then the nature of chlorine is what? Nature of chlorine is it is an electronegative atom, and magnesium it is a electropositive atom. What we are observing, that is addition of chlorine atom means addition of electronegative atom. Any confusion? No. Addition of chlorine atom means we can say that addition of electronegative atom to the magnesium. If the electronegative atom get added means it is same as oxygen atom. Can you say me what process we call it? Yeah, absolutely correct. It would be oxidase. It would be oxidase. Here the magnesium get oxidized into magnesium chloride after the addition of chlorine atom, which is the electronegative atoms. And since earlier we defined where does oxygen get added, that process is known as oxidation. That means oxygen we have as an electronegative atom, so we can extend these definitions for all those electronegative atoms which get added to any other atoms, and that process is known as oxidation. Any doubt? Now, see the same process with reference to the chlorine atom, magnesium chloride. Now look, chlorine atom is the electronegative atom and magnesium atom is the electropositive atom. What happens when the chlorine get converted to magnesium chloride? There is the addition of magnesium atom. The nature of magnesium atom is the electropositive, means what is happening? Addition of electropositive atom, and as we know that hydrogen is the electropositive atom. So what phenomena we call when the electropositive atom get added to any another atoms? That is known as reduction. Is it clear? So can we write here reduction? Now we observe here with reference to the chlorine, this process this takes place, that is reduction, and with reference to magnesium, this process takes place oxidation. Any doubt? So in this same reactions we can identify oxidation and reduction. It's okay? Oxidation and reduction both process. It's okay? Now look, oxygen atom get added, that is oxidation. So we extend this, elaborate this concept for those electropositive and electronegative atoms, such with reference to oxygen and hydrogen. How we define? If the oxidation takes addition takes place of electronegative atom, that is oxidation. So reverse of the reduction will be considered. Removal of electronegative atom is known as reduction. Addition of electropositive atom is known as reduction, and removal of electropositive atom we call the oxidation. So we can write addition or addition of electronegative atom is called oxidation, and removal of electronegative atom is called reduction. Now addition of electropositive atom is called reduction, and removal of electropositive atom is called reduction. Oxidation. Means we can, if consider, we expand this definition, we can say that the addition of electronegative atom, or you can say that oxygen we call the oxidation, and the removal of electronegative atom or oxygen we call the reduction. Addition of electropositive atom or hydrogen atom is called the reduction, and the removal of electropositive atom or hydrogen atom is called the oxidation. Now, problem 8.1 NCRT, identify the species undergoing oxidation and reduction. Let us see. First of all, remarks such as H2S get converted into HCl, and chlorine, H2S get converts into sulfur, and chlorine get converted into HCl. Now here the two process be marked, right? Now what happens? H2S to sulfur. So what changes we observe here? Removal of hydrogen atom. Is it clear? What we call if the hydrogen atom get removed? Yeah, absolutely. You are right. That is process is called as oxidation. Means H2 H2S here get oxidized. That is the species. H2S is a species which oxidation takes place. Clear? Now, chlorine. What is happening? Addition of hydrogen atom. Addition of hydrogen atom. And when the hydrogen get added, we call that process is the reduction. So, chlorine is a species here which is get reduced to HCl, and H2S is a species which is get oxidized. Means the species undergoing oxidation is the H2S and the species undergoing reduction is the Cl2. Is it clear? Okay. So dear student, here I have given the some homework questions for you. That is, identify the oxidation and reduction species. Which species is going to oxidize and which is going to reduce. Later, so here at last we can conclude that we can identify and define the redox process on the basis of oxygen and electronegative atom, and reduction and oxidation on the basis of hydrogen atom or electropositive atom. So that's all. Okay, पढ़ते रहिए.